Hey everyone, thanks for joining us. My name is Ben Weinberg. I'm a developer advocate here with the Axelar team. Just gonna give a minute or two for people to hop in before we get going. Cool. Okay, we actually have quite a bit to get through, so I'm gonna get going here. People can watch the re-recording. So let me just share my screen. So thanks everyone for joining. My name is Ben. I've been with the Axelar team since last summer. Today we're going to be covering building an Interchain game with Axelar GMP. So lots to get through, so we're just going to get right to it. I'm hoping this will take about an hour. It might be just a bit over that. So for anyone who has not heard of Axelar GMP before, it stands for General Message Passing. And at its simplest form, Axelar's general message passing enables a developer building on one chain to call any function on any other connected chain. And this is really powerful. It basically takes interoperability between two blockchains to the next level. It's a lot more now than just sending like a wrapped asset from one chain to the other. It's actually sending data or sending function signatures and having true composability between different blockchains. With Axelar GMP, you can interact with contracts on other chains as smoothly as if you were interacting with the contract on your own chain. And that's really, really powerful. So to visualize GMP in action, imagine we have two contracts, one on Ethereum and one on Avalanche. We could send something as simple as, hey, are we going to make it? Like a little hello world message. You can also send something a bit more interesting, like a safe mint function to mint a bunch of NFTs. So you can really see here the different degrees of what you can send. You can send basic data or actual function calls. So how does GMP actually work under the hood? And this is our last slide before we actually get to the exciting coding part. So imagine we have our transaction on, our contract on two different chains. We have a contract on Avalanche and we have a contract on Polygon. Okay. Now, every GMP message that we want to send via Axelar, we're going to have to trigger that interchain transaction via something called the gateway. The gateway is a contract which Axelar has deployed on basically every different EVM chain which it's connected to. Okay, the gateway exposes several different functions. One of those functions is a function called call contract with token, which basically allows you to send a GMP message along with an ERC20 token. So we have our dApp here. Our dApp has whatever functionality. We import the gateway, and then once we're ready to send this interchain transaction, we call this call contract with token function. Once we do this, the gateway contract will emit an event. This submitted event will then go to the Axelar network. The Axelar network, which is a blockchain governed by 75 validators, these validators will come to a consensus about this message that was sent. So in this case of like a WAGME message, they'll basically say like, hey, did Ben actually send this WAGME message? They come to consensus about whether I did. Once they did, then they mark the message as approved. Now on the gateway contract on the destination chain, so same contract, different chain, we get that message that the transaction was marked as approved. Then we have a function called execute with token, which will be defined on our dApp on our destination chain. And via something called relayer, this execute with token function will be called, and any message that was sent along with the token will be executed in this execute with token function. So in the case of like, let's say I sent WAGME, then I can emit an event on the destination chain saying WAGME. So one more time, I'll go through this because that was a lot. Our dApp interacts with the gateway contract via the call contract with token function. Gateway emits an event, goes to the Axelar network. The Axelar network comes to consensus about the message that was sent, marks it as approved. Once it's marked as approved, it's picked up by the gateway contract onto the destination chain. And then a relayer triggers the execute with token function, which is implemented in our own dApp. So for today, we're going to be building, as I said before, an Interchain game. And we're going to have two contracts that we're going to be working with. One is a game contract and one is a receiver contract. So what is the game on a very high level? Well, it's very simple. We're just going to basically be guessing a number. The number is going to be kind of pseudo-randomized. And then we're going to send funds with our guess. And if we guess the correct number, then we earn the pot, earn whatever is in the game contract. So that's going to be the logic in the game contract. The receiver contract, which is the second contract which we're going to be deploying, will basically have the logic of like checking if your guess was correct, and if it's correct, then pay out the funds. Now, the way to visualize this is because we're going to be going on different on different chains. We're going to actually be having interchain transactions. So the second contract that I mentioned, the receiver contract, will be deployed on the Phantom blockchain. Okay, and the game contract will be deployed on Phantom, BNB, and Polygon. In other words, you as the player have the option to guess or participate in this game from any of these three chains. If you're guessing and staking from from Phantom, then you don't actually have to do an interchain transaction because the receiver is on a Phantom. So you're going to be guessing. If you're right, you get paid directly on Phantom. If not, then your guess and your funds are on the receiver contract. You can also guess from Polygon. When you're going from Polygon, you're actually sending an interchain transaction via Axelar. In other words, the number which you're guessing between 1 and 6, that is going to be your GMP message that you're sending between the chain. And in addition to the guess that you're sending as your GMP message, you're also sending some funds to go to the pot. We'll also be on BNB doing the exact same thing. So you can guess and stake from BNB. And in the case that you win, let's say you guess the right number, then in one transaction, or in one click, I should say, the funds will be going from BNB to Phantom. It'll guess. And then the receiver contract on Phantom will be like, hey, did you actually guess correctly? If so, then automatically you are paid out all the funds. Now, what's really cool here is, obviously the game has access to a lot more different players because you're deployed on a few chains, but also the game has access to potentially a lot more liquidity, but different types of assets. So for example, someone from Polygon might have Wrapmatic more readily available than someone on BNB. So you will be paid out in different assets coming from different chains as well. So it's very powerful for that reason. So let's get to it. First of all, any questions so far on what we covered before we get to the coding part? I don't see any, so I'm going to move right along. So we have a starter code. I'll add this all to GitHub for you to take a look at. And you can see here, the first contract we have is our Interchain gaming contract. Second is Interchain game receiver, so corresponding to a game contract and receiver. Okay, let's just worry about the Interchain gaming contract for now. You see, we have a constructor. Let me actually make it a bit bigger so everyone can see. I'll close this for now. We have a constructor which takes in two addresses. First, the gateway. Remember, we talked about the gateway. That is this contract, which we're going to be used to actually trigger the interchain transaction. Every gateway contract exists on a chain that Axelar is connected to, so we're going to have to pass that in. Then we're going to pass in the gas service. Now, I have not spoken about the gas service yet. The gas service is basically a service which the Axelar team has made available for, well, as the name suggests, making gas payments easier for interchain transactions. So why does it matter? Well, let's say you are playing this game on Polygon, okay? And you want to make an interchain transaction from Polygon via Axelar to Phantom. Well, if you think about it, you're going to need 3 different tokens. You're going to need Matic for the Polygon transaction, AXL for the transaction going through the Axelar blockchain, and FTM, funds to pay gas on the on the Phantom chain. And I don't know about you, but I don't want to have to hold 3 different tokens every single time I want to make a transaction. And that's where the gas service comes in. It basically allows you to pay for a transaction in the token of the source chain. So in other words, I just need to pay this gas service in Matic if my source chain is Polygon, and it'll take care of paying the funds on the AXL chain and on Phantom. The money's still coming out of my pocket. It's not like subsidized, but I don't have to worry about actually holding all these different assets. It just makes for a much better UX. The last address we're passing in is the address of the game receiver. Remember the second contract, which we're going to be working on as well, and I will get to that further down. So the first thing we're going to want to implement is this guess number function. This is where we're actually going to play the game, basically guess the number between, let's say 1 and 6 to play and win this game. And as well, you're also going to want to stake funds, send funds to this to the receiver, which will be used to pay out rewards for the eventual winner of this game. So let's actually start to write this out. So first thing I said is that the number is going to be between 1 and 6. So I'm going to make sure that the guess that we're passing in is between greater than or equal to 1 and less than or equal to 6. If it's not, then let's say invalid guess. Okay. And actually, now that I think about it, let's actually explain these parameters quickly before we even implement them. So we already kind of touched on guess, which is just the guess for the game. But the first parameter that we're going to be using is the destination chain. So that is in the case that you're going from not from Phantom, because the receiver is on Phantom, so you're not actually sending an interchain transaction. But if you're going from Polygon to Phantom or BNB to Phantom, then you're going to actually have to say like, hey, what is the destination chain that we're sending this transaction to? So since the receiver is going to be on Phantom, we're eventually going to pass in the value of Phantom. But this is just the name of the destination chain that we're going to. The second parameter is what is the address of the destination chain that we're going to. So once we get to Phantom, be like, hey, where are we going? Guess, we just went over, it's the guess that you're making. Symbol is the symbol of the ERC20 token that we're going to be staking, that we're sending along with our guess. And the amount is, you can probably take a guess, the amount, how many of those ERC20 tokens are we going to be sending. So we've implemented our require statement to basically say like, hey, the number has to be between 1 and 6 that you're guessing between. Now let's actually make use of our gateway contract that we passed in. So with our gateway contract, we're going to want to grab the address of the ERC20 token that we're sending. So to do that, we call the appropriate function token addresses. We pass in the symbol. And voila, we have the token address now. It should be returned from token addresses. And this will be the address that we're actually sending between the two chains. And for the sake of this demo, I'm going to actually require that whatever token you're going to be staking has to be an Axelar compatible, a gateway compatible token. So basically, if the gateway was not able to find the address, in other words, if its address is 0, then just revert and let's say like invalid token. Okay. Next, we're going to want to make sure in the case that you're sending an interchange transaction that you pay some gas. So if you forgot to send a message value, we're going to say you have an insufficient gas amount. Great. So at this point, we call the number. We're going to make sure that we're passing in an accurate guess. We're passing in a correct token, and we're passing in at least some gas to pay for the transaction. Now we're going to want to actually deal with our GMP message. So remember, we're sending in the guess as our GMP message, but we're also going to be sending the player's address, player being message.sender in this case. So message.sender, that's actually ABI encode, message.sender, and guess. The reason we have to do ABI encode is because Axelar GMP expects the message that's passed in via type bytes. So bytes, memory, let's just call it like encoded guess for now. Okay. So now we have a GMP message which represents the player who is playing and the guess that that player made. Now that we have our guess, we can actually send our funds, our token, from our message sender's wallet to this contract. Then we want to approve our gateway to actually be able to handle funds on our behalf. So at this point, we have encoded our GMP message, and we have sent our staked amount from the player, to this, what's it called, to this Interchain gaming contract. It now holds it on our behalf. We're sending it, holds it on our behalf. Now we can get to the interesting part. Now let's actually deal with some of the Axelar services. Remember, there's two Axelar services that we're dealing with. We pass them in the constructor. There's the gateway, which, remember, triggers the interchain transaction. And second, the gas service, which assists with paying for the interchain transaction. So first, let's deal with the gas service. So we're going to call this function, which is defined on the gas service, so pay native, gas for contract call token, bit of a mouthful. We're going to pass in the message value, and we're going to pass in several parameters here. First is, who is this payment for? It's for this contract. And then we're going to pass in some of the relevant parameters that we described earlier. So the destination chain, like what is the name of the chain that we're going to? What is the address on that destination chain that we're going to? What is our GMP message? So that's line 37, our encoded guess. What is the symbol of the token we're sending? What is the amount of the token we're sending? And then lastly, and very importantly, is who is the refunded address? So let's say we're sending the transaction from Polygon to Phantom, and I'm just going to pass in like 10 Matic to pay my gas, let's just say. Now, the gas service is smart enough to know that if there was a surplus of gas that was sent, it will refund that gas amount to someone. So I want just the message sender to receive that refund if there is any. Great. And at this point, we have successfully paid for our interchain transaction. There's one more thing we have to do, though. Paying for it is not enough. We actually also need to send it. And that's where the gateway comes in. So with the gateway, we're going to use call contract with token. I'm actually even just going to copy and paste it straight from the slide. And this will take several parameters. Very similar to the gas service, actually. So it'll take in, not that similar. It'll take in the destination chain, the destination contract address, our GMP message, which is our encoded guess from line 37, the symbol of the token that we're sending, and the amount of the token that we are sending. And that is it. Now, once we call guess number, we will have made sure, after passing the require statements, we will send the ERC20 token from the EOA, to this contract. We will then pay for the interchain transaction with the gas service and actually trigger the interchain transaction to actually send my guess, what was my guess, and however many ERC20 tokens I have passed in. Let's see if there's any questions here so far. Hello all. Okay, if any questions, feel free to just ask away, but I'm going to keep it going for now. So this is all great for if we're guessing, if we're playing the game on Polygon, or if we're playing the game on BNB. In other words, we're sending an interchain transaction. But what if I'm playing on Phantom and I want to not send an interchain transaction? We want those people to be able to play as well. So let's actually implement some logic for that very quickly. We're going to go if the destination chain is basically empty. I don't think we can do that in Solidity. We actually have to convert it to type bytes, and then basically just check the length is equal to 0. Oops. So if the destination chain is empty, and to be extra safe, let's also go if the destination contract address is empty. In other words, we're not specifying a destination chain that we're going to, then we can assume that that there is no destination chain and that we're playing the game from Phantom itself. In other words, we don't have to do an interchain transaction. So if we are actually specifying a destination chain and a destination contract address, then we can assume that we are sending an interchain transaction. So let's throw all of this, what we did before, in the else case. And in the if case, so let's leave a comment here. Interchain TX from chain A to chain B, and then no interchain TX sending on, or let's say make it more fun. Playing on the same chain. Spell everything right? Looks like I did. So if we're not actually sending an interchain transaction, it's going to be way simpler. All what we're doing is I'm actually going to just copy and paste this code. We're calling transfer from. Instead of going to address this, though, we're going to be sending to the game receiver. And yeah, we're sending from me. We're sending this amount, and instead of this address, we're sending to the game receiver. Because remember, the game receiver is going to be deployed on Phantom. And then we will, and I'm not going to go over these functions yet. I will go over them in a bit. But basically, we're just going to be calling this check if winner. So basically saying, hey, was your guess correct? If so, then pay me. So this means the guess, the symbol of the token, and the amount of the token. Don't worry about this check if winner for now. We're going to come back to this later. So again, now we have the complete guess number. So this is, for anyone playing the game, going to go right through this function. So let's say I'm playing from BNB. I'm going to specify the destination chain and the destination contract address that we're going to, specifying my guess and the symbol and the amount of the token that we're going. If we do have a destination chain and destination contract address, then we can assume it's an interchain transaction. And in that case, we want to go through this whole flow of actually paying for the interchain transaction. And that consists of talking to the gas service, calling pay native gas for contract call with token, specifying all these different parameters that we need, sending the message value, and then after paying for the gas, actually triggering this transaction from our gateway's call contract with token function, exactly as we had specified in here with the call contract with token. And if we're not sending an interchain transaction and we're just going on Phantom, then we're just sending the token from me to this contract and calling the check if winner function. Now, let's actually deal with this else case. So at this point, we've paid for the interchain transaction, we've sent the interchain transaction, but recall this diagram. Once we send it, it's not enough. We actually have to handle this interchain transaction on the destination chain once it gets sent over. And that execute with token function is what we're going to be implementing in our second contract, our interchain game receiver. So again, the difference between these two contracts, I'm going to just pop back to the slides. I'm sorry if I'm repeating myself. I just want to make sure everyone's crystal clear on it. We have our game contract, which exists on any different chain. This is the contract which players are going to be guessing from. We have the receiver contract, which only exists on Phantom, and that's going to be basically checking like, hey, who won, and then paying them, paying the winner, whether the winner is coming from Phantom or from one of these different chains. Okay, so let's actually hop over to this interchain game receiver contract. So the first thing we want to implement is this execute with token function. Okay, remember, execute with token is this guy, step 4 on the GMP chart. So it's actually going to be very straightforward. We're going to call check if winner. Sorry, my cat popped in. Check if winner. We're going to be passing in the payload, which I will explain what the payload is shortly. We're going to be passing in the symbol of the token that was sent. We're going to be passing in the source address and the source chain. I'll explain all this very shortly. Source chain. Okay, so I'll explain what these parameters are first before actually implementing all these functions. The payload, if anyone wants to guess, what is the payload? It is the GMP message. Remember, this message that we sent across the two blockchains. Our GMP message is, remember, line 43, our encoded guess. This guess is our GMP message. So that is what we're going to receive as the payload here on our destination chain. And what is the GMP message? It's just an encoding of the message sender, in other words, the player, like who's making the guess, and B, what was their guess. So that's the payload. And then what is the symbol? So symbol is the token that we staked, that we sent along with it. The source address is, where is this call even coming from? Is it coming from BNB? Is it coming from Polygon? Is it coming from Ethereum? We get that right out of the box with our execute with token function. And then what is our source chain? So source chain was where is this call coming from? And source address, I should have put this in a better order. And source address is, what is the address on that source chain? Who is actually sending me this transaction? So we know that the call is coming from BNB, let's say, but who's sending it? And it is going to be this contract. This whole Interchain gaming contract is the sender of this transaction. Now, how do we get all this? That's because it's coming from our Axelar executable contract here, which we're inheriting. That's where execute with token is actually defined. You see there's some other stuff going on here. I'm not going to step through that. We have other content to cover this. But all you have to know is that we inherit from Axelar executable, and then we get this execute with token function for free, as well as all this cool functionality, like where is the source chain, what is the source address, what is the payload. Any questions so far? Will the stream be available? Yes, it will be available after. Yeah, 100%. This is a lot of content. So this will be available on YouTube after, and you guys can rewatch it and even follow up with me after if you have any questions. Great. So at this point, we are calling this check if winner, and we're passing in these 4 different parameters. Notice here in the constructor, it's basically the same as the previous constructor. We're passing in the gateway and the gas service. I'll get to this unique tokens function a bit later. So we call this check if winner. The issue is that we don't do anything in check if winner. So let's take care of that. So we pass in the payload, which is the payload coming in from here, the symbol, basically everything I just said, we're kind of just passing into check if winner. So first thing we're going to want to do is, remember, this payload is our GMP message. So we encoded it here on line 43. So let's now decode it here on our destination chain. So ABI decode, we're going to be passing in the payload. And what do we want? Well, remember we encoded message sender and the guess, which is of type address and of type UN256. Now we can grab our player's address and their guess. And just like that, we now have a message that was sent from the source chain, and we are received and are going to be handling it now on our destination chain. And that's pretty cool. So let's actually do something with it. First thing we want to do is we'll check if you're the winner. So let's actually grab the dice results. And we're going to do super pseudo randomness here. For any production app, you would not want to calculate randomness this way. So just for the tutorial for now, you want to go through like through an oracle or something to get true randomness. But for now, this is all we need. In fact, you know what? I'm actually not even going to do it this way. I'm actually just going to pass in the dice result as 5 because when we're testing it and I want to see if we won, I don't want to have to play this game 100 times to actually try to get the right number. We're going to know that the winning number is 5. But I'll make sure to push it with line 37 instead of 38. Okay. Now that we have our winning result, we're going to call this add unique token symbol function, which is our next function here on line 43. So let's pass in the token symbol. I need a semicolon. So remember we had this array in storage here, unique tokens. Okay. And what are we doing here? Well, remember, we want to have the flexibility for our players to not only require them to stake one type of token. So imagine, let's say, Axelar USDC. You could trigger this interchain transaction, make your guess, and send a USDC to the receiver contract to basically hold the entire pot. But what if we want to give them the flexibility to send wrapped Matic, wrapped BNB, any different asset, which is compatible with Axelar? That's what we're going to try to do here. So set this found false. You'll see why in a second. So we're going to basically loop over this unique tokens array, which will basically hold all the different token symbols that are collected in this pot. And then we're basically going to be like, hey, does unique tokens at a given index, actually we have to have a hash of it. It's hard to compare strings in Solidity. So bear with the funky syntax for now. Kekak 256. Great. So now we have a hash of this token and being like, hey, if it's equal to, again, hash ABI encode to a symbol that we have. So basically, if the symbol that's being passed in here is equal to a symbol that we already have in this array, then we can say, hey, we found it. And don't actually add this. So break the loop. And basically, that's it. We're done. We already found it. This token symbol has been registered. Again, probably not the most efficient way to check this, looping over potentially a giant array. For the sake of this demo, we're just going to kind of roll with it, but I'm sure there's probably a more efficient way that we could check this before I get called out on that. If, however, the token was not found, then we're going to push that symbol to our list of token symbols. So let's say I've bet in AUSDC, then, or Axelar USDC, then we register that token symbol in this array. Now, as soon as I register, if another player bets in Axelar USDC, then it knows not to duplicate the symbol in the array because of what's going on here. If we pass in a new token symbol, then we push it, and now our array will contain of AUSDC as well as the new symbol, like let's say Matic or something. Great. So now we have our add unique token symbol. Let's finish off this check if winner. We're basically going to say, hey, if your guess that we passed, remember we decoded it here and we have our guess on line 35. If it's equal to our dice result, which is basically just 5 now, then congrats, you won. If you won, then let's actually call this last function we have here, pay out all tokens to winner. How are we thinking? Not bad. This pay out all tokens to winner will take the player. It'll take the source address and the source chain. Okay. So basically, if the winner is on, remember this contract is going to be deployed on Phantom, but if the winner is on BNB, then this contract will have to know, like, hey, which blockchain am I going to be sending this winner's funds to? That's why we're passing in the source chain and the source address. And the source address is like, where on that destination chain are we sending the funds to? And then the player is like, well, who won the game? And you'll see why we need that momentarily. And that is it for our check if winner function and our add unique tokens. So now let's recap where we are. I have played the game, let's say from BNB. So I'm hitting this else case. I place my guess. This gets encoded along with my address to a GMP message. I send my ERC20 tokens to this contract, to the Interchain gaming contract. I pay the gas for the Interchain transaction with the gas service. I then call contract with token on our gateway to fire off this Interchain transaction. And this call contract with token requires the destination chain, where are we going, where the destination contract address, where on the destination chain are we going to, what is our encoded guess, which is our GMP message. So what is our message that we're sending to the destination chain? What is the symbol of the token that we're sending, and what is the amount of the token that we're sending? Once that interchain transaction has been sent, remember we're following this diagram here. So at this point, we've sent the transaction. It goes to the Axelar network. The Axelar network comes to consensus about the GMP message, marks the message as approved. We hit the gateway, and then we hit our execute with token function. This execute with token function is going to be defined here on our Interchain game receiver contract. Once we hit this, we call check if winner, and we pass in the different parameters we need, including the GMP message, the symbol of the token, and where the transaction is coming from, the source address and the source chain. The check if winner then decodes the GMP message, so we have our raw values of the message sender and the guess that the message sender had. We check if there's a unique token symbol which the player has basically staked. We check if the player has won, and then if we won, then we get to this function, which is what we're going to implement now. Is that clear? Let's see, any questions? I can't watch videos on another website. Yeah, it'll be later on YouTube, guys. We'll make sure it's there. I understand it's a lot to take in one sitting. So I'll make sure it's on YouTube, and you guys can watch it as many times as you want. Great. So at this point, we want to pay out all the tokens to the winner if that winner has won. So first thing we're going to want to do is we're actually going to want to create a loop. Why? Because we're going to be paying out all the tokens in this pot, not just native tokens, but all the ERC20s that that are in this pot. So we're going to have to actually go over each of the symbols in this token array, in this unique tokens array, and pay based on that. So we're going to loop over unique tokens. And then for each token in the array, we're going to just grab the symbol here this way, just for readability purposes. Now we're going to grab the address of our token. Remember how we did that when we were sending the transaction? It's the gateway contract actually has a function just for this called token addresses. So we pass in the symbol, or I should say each token symbol, and then we grab the token address of each token that we're going to be sending back to our winner. We then want to send in the complete amount that this token actually, that this receiver contract actually holds. So transfer amount is our token address, a balance of this this contract. So address this. Sorry, cranky cat. I think she's gone. Okay, so now we know exactly how much of each token we're going to be sending to this winner. For the sake of this, just in case anyone was wondering, for the sake of this demo, I'm not going to be worrying about like proportionality. So if the winner just gets the whole pot, it's not really based on how much that user staked. Obviously, if this were production, we'd have to worry about that. But for now, I'm just going to worry about sending the messages and transactions back and forth. So first thing we have to, the next thing we have to do, I should say, is approve, just like we did when we were sending the transaction here. Now that we're sending the transaction back to the source chain, we're going to have to approve the gateway address on our destination chain to actually send funds on our behalf. And now we're going to call our call contract with token function again. We're going to be passing in the address, the blockchain we're going to, which is the winner's chain, the source address, which is going to be our Interchain gaming contract, and you'll see why momentarily. We're going to pass in our GMP message. I'm not encoding it on a different line the way I did here last time when I was encoding the GMP message. I'm just going to do it in the function itself. It's because our GMP message is just one parameter this time. It's just the address of the player. We're also going to be passing in the token symbol, so the token that we're sending, and the transfer amount. So each, basically each time this gets sent, it's going to be with a different token symbol. Sorry, a different token and a different transfer amount. Great. So at this point, once you know that this player has won, this payout all tokens to winner function will be triggered, and it'll loop over each token and send that token to this source address on our destination chain. Nice, we're just about there. Our last function now. So remember, take note, this is sort of like a ping pong. We guess the number, we check on the destination, we guess the number, we hit our execute with token. Execute with token will basically check if your guess was correct. If it is correct, then you're going to call the gateway again, kind of like a callback function, and trigger another Interchain transaction to go back to the Interchain gaming contract. And now, just like how we needed an execute with token function to handle the transaction going to the source chain, we're also going to need an execute with token function, which we have written up here, to handle the transaction coming back from the destination chain, because it's a two-way contract that we're doing here. And this logic here is going to be very, very straightforward. This time around, we're literally just going to be taking the player. Remember, our GMP message that we sent was, where is it? Is this player encoded? So we're going to decode the payload to give us the address of the player. We're then going to grab the address of the token from our gateway contract once again for the third time now. And we're going to simply call transfer on that token. And who's going to be receiving it? Well, the player is going to receive the amount. Note, these are the same parameters that we received here. I'm just using different ones than I was using before. In this case, we don't need the source address. We actually don't even need the source chain. We just need the payload, the GMP message, the symbol, and the amount. And that is it. We are done. We notice we have these extra functions down here. What these are, it's actually, if I pull this up here, the exact same check if winner, pay out all tokens to winner, and add unique token symbol. I guess in a different order. Sorry. But we have it built into the Interchain gaming contract as well. Why? Because if we are playing this game from Phantom itself, then we don't need to do, we're not going through the whole interchain transaction. We can just actually run all this logic on this interchain gaming. And that's why, if you recall up here, we were calling check if winner directly. That's because it's all can just be computed here. But if we are doing an interchain transaction, we're actually sending assets and a callback function. Remember how we're sending a second transaction here. That's when we actually need to break this up into two different functions. One more thing I want to call out. If you notice, some of you may be wondering that we did not actually call the gas service here. We only called the gateway contract. So remember here, when we were sending this initial transaction, we called the gas service and the gateway. And that's because this is going to be a callback function. So it'll use the gas from our initial transaction. And if I have written this correctly, bear with me, it is live coding. This should hopefully compile, and let's test this guy out. Any questions before we start running this? Okay. Yeah, looks like we've been handling the questions here. Thank you very much. So let's compile. Let's see if this compiles out of the box or if I miss something. Sweet. Actually worked, but never compiles for me on first guess or on first compilation. So let's deploy. I've written the deploy scripts before. You can check it in the code I'll push to GitHub. Let's deploy it to Phantom. Remember, Phantom should have the receiver contract and the game contract. So we'll see actually two addresses get logged here. Great. Contract, which is just the interchain gaming, this first contract that we have, and receiver, which is, remember, this second contract which we wrote up. Okay, let's actually play this game. I'm gonna interact with this via the hard hat console, and hopefully we don't have any issues here. I may have missed something typing this up, but hopefully we should be smooth sailing. So first thing we want to do is call this contract. We want to get an instance of our contract. Now that we have an instance, let's see. We should be able to call like a public variable here to see if it's working. So let's say I want to call this gas service variable here. Nice. We're able to actually talk to our contract. So what do we want to do? We want to call guess number. So the destination chain, because we're playing just from Phantom, so we don't need a destination chain because we have the receiver already deployed on Phantom. So we're going to set the destination chain to empty and the destination contract address to empty. Let's set a guess of 1. So we have the dice result to 5. So 1 will lose. If we do 1, we want to lose right now. We just want to build up some funds in this contract. So we set the guess to 1. We set the symbol of the token that we're sending to AUSDC, and the amount, let's set to 2 million, which is just 2. It's 6 decimal points for AUSDC. And if we call this, execution reverted. Why is that? Transfer from. Let's see. Did I approve this token correctly? Game interchain target. I did. Let's see. Okay, I'm assuming I must have missed an approval somewhere. For time's sake, I'm actually gonna skip sending on Phantom to Phantom. I'm gonna jump right to sending from Polygon to Phantom. And I can come back to this later. So let's actually deploy again on Phantom, and I'm gonna also deploy on Polygon. And I'll actually come back to this later to try to get this Phantom transaction working. Let's see, hopefully the Polygon one works right off the bat. So now we've deployed the contract on Polygon and on Phantom. Let's again set up an instance on Polygon. And attach this address. And now let's guess the number again. But this time we're not sending empty strings. We're actually going to be sending we're actually going to be specifying the destination chain that we're going to. So that destination chain is Phantom. The address on the destination chain is the address of the receiver contract. And we're going to be sending to a USDC. Hopefully this works and we're not reverting. No, we're reverting again. Oh, insufficient gas this time. Let's see. Do I have gas? I do have gas. Let's see. Why is this reverting? Insufficient gas. Murphy's Law of live coding, everyone. Let's see if any questions so far. Oh, I know why. Anyone know why? We actually did not send any gas. So let's actually send some gas here. So value, and I'm going to send in 18 zeros here. So hopefully I count this correctly. 1, 2, 3, 1, 2, 3. Okay, now it's working. So yeah, it reverted before. Why? Because of this require statement. I actually forgot to send gas when I was sending my Polygon to Phantom transaction. So it's good. At least we know a require statement is working correctly. Now, I'm actually going to take this chance to show off a cool feature that Axelar also has. So see how we have the transaction hash of this transaction on Polygon. So I can actually go to Mumbai.Polygon scan, and I should see this transaction on Polygon scan shortly. It's just getting finalized or getting added here. But if I want to actually, remember, we're doing a lot more than just sending your typical Polygon transaction. We're actually sending, there it is. We're actually sending this transaction from Polygon to Phantom. So we have a really cool block explorer called Axelar Scan, which we can basically see a bunch of neat stats about Axelar Scan here. These are stats just for the testnet for now. But I can actually take this transaction, throw it into Axelar Scan, and I should be able to see momentarily this transaction appearing on Axelar Scan. And now here you can see a much more clear view of the transaction than just looking on Polygon Scan. We can actually see the transaction going from Polygon to Phantom, to our receiver contract there. We can see the step-by-step of the transaction. Basically, a much prettier way of seeing this chart that we were going through in action. So we can actually see the transaction was sent. But what's really cool, I can even see the logo of the block explorers here. So I can click on it and it'll take me to the native block explorer. But I can see the transaction being sent. I can see the gas being paid. Remember with the gas service that we had wired up here before. The transaction is just being finalized on a Polygon. And then come back in a few minutes and we should see it being executed in Phantom. In the meantime, while this is going, I'm actually going to play this game on another blockchain. I'm actually going to deploy this onto BNB and go from there. So I already have this contract. I'm going to do it through Remix this time, not through the hard hat console, just to mix it up. So we have our gateway that we need for BNB. We have our gas service that we need for BNB and our game receiver that we need. So the game receiver is going to be the address on Phantom. And let's deploy this. Hopefully it works. It does. And in a second, we should see the transaction actually appearing here. Wait, am I on? Oh, I'm on Polygon. Sorry. Let me actually go to BNB and deploy again. Okay. Let me actually just refresh this. Mix can be a bit glitchy sometimes. So game, paste this in, and go to compile, injected Web3 provider. So I know we're getting a bit low on time. BNB, so let's throw in our parameters here. I'm actually gonna go right to the Axelar docs to grab this, so you can see where in the future, if you want just to know where some of these contracts are listed, you can go to the Axelar docs, and I'm gonna be deploying on BNB. So I grab the gateway right from here. I throw it in the gateway. I grab the gas service, throw it in the gas service. I grab the game receiver like I did before. Remember, that is the address on Phantom that we deployed. And I'm gonna throw it here. Pending, Great. This time we actually deployed it on BNB. So let's just give it a second here. Okay, so we got it. And now let's go right to the guest number. So the destination chain, same as last time, is going to be Phantom. Destination contract address is going to be our game receiver. Let's just grab that here. Our guess, for time's sake, I'm just going to do 5. Let's just do the winning guess here. The symbol, we're going to do a different symbol this time. We're actually going to do wrapped BNB. So this is the really cool part, where we can not only interact from different chains, but we can also use different assets that might be more readily available on different chains. In this case, wrapped BNB coming from the BNB chain. And the amount, I don't think I have very much BNB. I have like 0.05. Let's just send this amount. One thing I have to do, or else the transaction will revert, I actually have to approve my address to send, because remember, we're using a transfer from here. So let's just approve this guy to send a bunch of wrapped BNB. And then once we approved it, we should be able to send a transaction from BNB to Phantom. And let's also send in some gas, or we will have the same reverting message that we did last time. Let's see, this is sent. Cool. And now hopefully this works. It does. Great. This transaction is still being finalized. I probably should have waited for this to be complete. Any questions so far? Appreciate the kind words, everyone. But yeah, that is basically it. So this transaction, you know what? I actually may have not, or I know I didn't send enough gas for my second BNB transaction. So you're going to see another kind of neat feature of Axelar Scan right now. So let's go back. You see my second transaction here is appearing, BNB to Phantom. And you see it's actually getting mad at me. It's saying insufficient base fee because I only sent like, it's gone now, but it was not very much. Like, so is my transaction lost? No. Oh, here's how much I paid. 1 to the power of 8. And I'm also sending very little wrapped BNB as well. But is my transaction lost? No, I can actually directly through the Axelar Scan Block Explorer. I can also do this programmatically via something called the Axelar JS SDK. Basically just top up this transaction to basically send more funds so that I can unblock this transaction that was stuck. And you see this guy's being finalized on the BNB chain. It's much quicker than on Polygon, just quicker finality time on BNB. Let's see, was this transaction sent? Okay, this should be done. I'm just going to wait for this guy to go through before actually, no, I'm just going to unblock it now. So I press add gas, and now it's going to prompt me to basically add some more gas to cover the transaction. I click confirm, and now we're off to the races. What are we doing? We are stepping through the Interchain transaction, remember, which I was explaining here. This sometimes you can confirm it yourself, or can wait for it to be confirmed automatically. For time's sake, I'm just going to confirm it myself here quickly. But normally this goes automatically as well. And that's it. We should see this whole thing going soon. This is an event that's just basically still being confirmed. Should go through momentarily, I hope. But yeah, any questions right now while we're waiting for this to be confirmed? There it goes through. Nothing yet. So now we are on step 4, which is basically going through. So let's actually go through these steps. 1, we sent the transaction from, let's go through here. We sent the transaction from Polygon. We pay the gas. Notice here we have the Axelar symbol, not the Polygon scan symbol. This transaction actually gets confirmed on the Axelar blockchain itself. Now it's getting marked as approved on Phantom on our gateway contract. And then the 5th and final step is when we'll actually execute. So that's when we'll trigger this execute with token function that we defined in our game receiver function, which should all hopefully go soon, very quickly. Yeah, any questions? I know we have to wrap up in a few minutes. If this is not finished executing by the time we hit the top of the hour here, I'm going to post these transaction hashes online. But yeah, any questions, please let me know. If you know anything about cryptos or something. Okay. Thanks very much. See, approve. There's one more thing I was hoping to show you guys. If the transaction can get through quickly enough. Let's see, did the BNB transaction go through? It's also still getting approved. Let's just wait for this to finish executing. Sorry, but that's typically a lot faster, but again, kind of Murphy's law of live programming. This code will also be, I'll make sure that's available for you guys, so you can clone it, play around with it. Basically, what I'm hoping will happen once this transaction actually does go through, and I'm specifically talking about the BNB to Phantom one, because remember, the BNB one, I passed in the correct value of 5. So this transaction is going to win the game. And what we're going to see, hopefully momentarily, is a callback function. The callback function, if you recall, is in the Interchain game receiver. This payout all tokens to winner. Remember, is calling call contract with token again. So we're going to actually see the kind of ping pong transaction of it going back from Phantom to BNB to actually pay out the winner of this transaction, of this game. We should go see it going through any second now. Nice. Okay, so the transaction was sent from Polygon to Phantom. So at this point, there should be 2 AUSDC on Phantom. And now, great, this transaction also made it to actually executed here. To Phantom from, whoops. From BNB. So let's see if we hit the execute function. You can actually see here, if the final step here, I can actually press it. It takes me right to the Phantom destination chain. And I can actually see the AUSDC was sent to 48588, which is my Interchain game receiver, which we deployed earlier. So now this has access to the 2 AUSDC. Doesn't look like the Phantom Explorer can show me the different tokens the way some of the other explorers can. Okay, great. This executed. Good. Now this is what I wanted you guys to see. So now the BNB contract, which went through, notice how there's this blue button over here. This guy did not have it. Why? Because there is no callback function. Why? Because this person guessed the incorrect number, so there's no payback transaction, so to speak. There's no reward going to him. And the winning transaction number is coming through a callback function. So if I click on this, this takes me to yet another transaction, which should be from Phantom now back to BNB. What is this? That is this payout all tokens to winner in our Interchain game receiver being executed. So this is calling call contract with token. Once this gets called, it's going to hit this execute with token function back on our game contract. So we didn't send enough funds, so I'm just going to top it up from here. And this is just one of, it should be 2 transactions. The AUSDC transaction should also be sent because remember we sent USDC as well. And that's it. We're going to have to wait for it to finalize once I top up the gas. And we will have winning player who played the game. And yeah, we're at the top of the hour here. So thanks everyone for joining. For further resources on this, I'm going to post those working transactions shortly. But if you guys want to learn more about Axelar, I'll urge you guys to check out these 2 links. You can just scan your computer. On the left is a bunch of different tutorials that we have on a repository called Axelar Examples, which basically shows examples similar to this, like 2-way transactions, vanilla GMP transactions like Hello World, sending tokens, sending NFTs, lots of different examples there. Some of them even have front ends, which is pretty neat. So highly encourage you guys to check that out. That was on the right, the Axelar examples. On the left, we have videos, which we have from the DevRel team. So similar tutorials to the one that I just did, and other kind of shorter tutorials showing how to do the basics of GMP transactions, staking tokens, using Interchain token service, which is a new feature that we just released. So highly encourage you guys to check out the tutorials, the video tutorials that we have, as well as our code repo that we have for other similar examples to this. And again, really thanks everyone for joining. My name is Ben Weinberg. I'm a developer advocate with the Axelar team from Toronto. Anyone who's in Toronto, hope to connect you sometime. Any feedback you guys have on this talk, let me know. I'd be super grateful for it. And thanks everyone for your time. This guy is still going through here, but I will make sure to post this when we're done. Thanks everyone for joining. My contact info, I'm going to post it here in the comments. If anyone has any questions, you can send me a message on Telegram or on our Discord or on our GitHub support repo, and I'm happy to chat. Thanks everyone.